My name is Lea, and I'm a software engineer. For the last 6 years, I have been working at FundApps, a regtech company based in London. You might have heard this in previous talks, but if we can help the conference crew with cleaning up, the green cards, just put them in the little basket on the way out. The yellow and the red are fine, they can stay there. They should be there. What I'm going to share with you today is a real story, a challenge that we in FundApps faced as a bootstrap scale-up that started signing more and more clients and larger names. We needed to re-architect our platform to be able to support our growth, but we also made it cheaper, faster, and greener. And with this last part, greener, I want to invoke a sense of urgency in you. I want you to leave this room with ideas, with a lot of questions, and I want you to talk to each other about it after this talk, not during the talk. And I want you to talk to me about it. So find me after the talk or find me in the venue. I'll be around today and tomorrow. It is so important topic for so many reasons. Since the last time I did this talk in January, this book came out. I was pretty happy it already aligned with what I was talking about. Has anyone read it? Ah, cool. I'm going to share something new with you today. This is the book. It has a lot of my notes in it, so you're not getting it. But it has in one place a lot of information backed up by research and in a very practical manner of what you can do, what you should do to make your software greener, and why. I will be sharing some of those tips with you today, later on. As I said, today I'm going to share with you the journey that we in FundApps took as a startup to build a more sustainable future for our business, but also as a B Corp for our environment. How many of you have heard about B Corp? Nice. Okay, a couple of hands up. The real definition is right there at the bottom. But what B Corp certifications really are is they allow companies to signal that they care about something else or something more than just profit, that they care about the world. We have been on this journey for 4 years, and we started with a monolith application that was in a single process on a long-lived infrastructure. And we re-architected it into cloud-native distributed application in AWS. I'm going to share with you today what challenges we had, so why we need to re-architect the platform, and how we went after those challenges. But before I'm able to do that, I think it's important for you to know who we are and what we do, and then to use that to frame your thinking. FundApps provides compliance as a service to investment management industries. Our clients are banks, pension funds, hedge funds, different asset managers. Our main service is shareholding disclosure. What that means is that when investment management, when they cross a threshold in owning an investment, a share in a company, they need to disclose. So let's say I buy 5% shares of Novo Nordisk. Now, aside from the fact that I would probably be somewhere on a beach, sipping pina colada, and not being here, I would need to disclose this to the regulators. I would need to say to the world, hey, I own 5% of these shares. It's not just a courtesy call, it's the law. And if I didn't obey with that law, it could seriously damage my reputation, it could make a serious dent in my bank account, and in some countries, I could even end up in jail. And on top of that, the deadline to report these disclosures is sometimes even the day after making a trade. Now, this is where it gets complicated. There are shareholding disclosure laws in 103 countries. And they could change. They change fairly often. Keeping up to date with the details of each of those regulations It's not easy, especially if they could be triggered even with the events that are outside your control. So I'm there on a beach sipping that pina colada. I'm not touching my shares. I like them. I want to keep them. And all of a sudden, another company wants to buy Novo Nordisk. And I need to disclose. So it doesn't stop there. Let's say I'm based in Denmark and I buy some Croatian shares. I need to disclose it to the Croatian regulator. So it's not just that I need to understand the Danish law, I also need to understand all of these regulations in all of the countries of the shares that I have. It's a little bit crazy to think that every investment company would have their own team of regulators and engineers to be able to interpret this regulation, but also to keep up to date with these changes and events. FundApps provides service to investment management industry to do exactly that, to outsource the process of knowing when they need to disclose. We monitor over 17% global, 17% assets under management on a global base for shareholding disclosure for 150 of our clients, which is over 20 trillion US dollar. We were founded in 2010, which means we have been around for a while. And what is important for today's story is that we have been bootstrapped. That means we didn't have any injections of money to rebuild things. And it means that we need to be very lean and practical, especially at early ages. Our mission is to make compliance simple through automation and through community. Let's say one of our clients is Enigma Capital, a hedge fund based in Denmark. They would, on a daily basis, send us a snapshot of their end-of-day positions through UI or through API in the form of XML. At the heart of what we do is a very complex and bespoke rule engine, and we use it to model the regulation. The rule engine will take those positions, and it will run a set of regulatory rules on top of it. And then it will generate some results. We take these regulation, the information from a law firm, and then our in-house team of regulatory experts interprets that information, codes it into rules that are then used by all of the FundApps' clients. When our clients get these results, they will continue with their daily workloads. They'll review the results, and they'll potentially then also disclose to the regulators. Now, in order to better explain the challenges we have, we need to go a little bit deeper into the rule engine. We said that Enigma Capital gives us their positions on a daily basis. But how does that XML look like? Every position will have a set of properties attached to it. ID, quantity, price, currency, total shares of outstanding. Every one of those properties belongs to a portfolio, to a group that we call a portfolio, and that represents a legal entity on our client's side. So that portfolio can be an individual investor, let's say me, by owning 5% of that big company, or it can be an investment manager, Flavia, that works for a company and that handles a set of investments. The rule engine will then take those positions, it will validate them, and it will also then calculate a set of properties on it. So in this case, price in euros, which will then be used by the next step that is going to calculate these rules, and then also on each one of these portfolios, so on mine and on Flavia's, and it will generate a set of results that will store into database. These steps validate, plan, calculate properties, and then calculate the rules while generating results and storing them to database. These need to happen in sequence. But the individual operations inside each one of those steps could happen in parallel. In practice, our clients will have over tens of millions individual positions with hundreds of properties attached to it. Each one of those positions will then be subdivided in a portfolio. And some of our clients have very complex internal structures, which means they could be having over 50,000 portfolios. The rule engine will then take those portfolios and run rules over them. We cover over 100 jurisdictions, and we have over 500 rules. Now combine that, and boom. We are talking here of an order of tens of millions individual rule calculations. And I'm not talking about adding two numbers. I'm talking about rule calculations that are potentially happening over millions of positions. What's important here as well is the time frame. Because if those deadlines are on the same day when the client is giving us these positions, it doesn't give us or the client much wiggle room. And nowadays, for most of our clients, this process takes 5 to 15 minutes. But for some of our more complex clients, we committed to under 60 minutes, which has been a challenge at some points. Let's take a look at why that was a challenge. When FundApps was founded, the rule engine was built with technology available in 2010. What will not come as a surprise is that we built a monolith. We had a small farm of relatively large Windows boxes that were doing the work, that were running the rule engine. And the database was a SQL server, again, running on another set of relatively large Windows boxes. During a week, when the markets were open, once a day, usually, our clients would give us their positions, which means that these big, massive Windows boxes were mostly just sitting there around and doing nothing. They're basically wasting their time. And even if they were being shared between multiple clients, their utilization was still around 20%. In order to support a burst of compute, we needed to have those machines over-provisioned and always on. So we wouldn't be impacting our clients' processes. We needed these position files to run fast. And this was really expensive, even if it was shared between multiple clients, which with time started causing more problems. Clients impacting each other started causing noisy neighboring problems. And this manifested into these position files taking longer time, being completely unstable. We could not predict the time, how long it took. And we could even see more often file failures. Even with these over-provisioned boxes, we were still struggling to support our clients, the biggest ones, and to isolate these noisy neighboring problems. And to be quite honest, there were some workloads, some clients that we were not able to support, even with the biggest AWS boxes at the time, which were 1 terabyte. So for this client, with the 1 terabyte box, this process took over 16 hours. I don't need to explain that this client didn't really get much value out of it. Our profitability was 0. And we lost this client. Additionally, the rule engine was generating a lot of data, which meant that this database started having a lot of data in, and we started having backup issues. On the worst days, we would generate 300 gigabytes of data, and at the time, with replicas and backups, all of that was around 400 terabytes. And this was for SQL Server. That's a lot. It's not meant to hold that. Additionally, with all this always-on and self-hosted infrastructure, we had all of these problems of patch management, drifting configuration, weekend work. We basically had a maintenance nightmare. So with this infrastructure and with these challenges, it would be very expensive to support any larger and any more complex clients. And we were worried that we were not able to support them, which would be commercially dangerous. Which means that the rule engine became a serious business bottleneck, but also sales barrier. This was us in our old office in London. And let me paint a picture for you. It's morning, it's Monday morning, and I have my coffee next to me. Now I have tea. And I open my rider. I'm ready. I'm in that flow, that happiness that Damien talked about yesterday. And all of a sudden, my phone starts to ring. Page duty alarm, page duty alarm. I was like, fuck. And then my colleague's phone starts to ring. I'm like, this is not good. Check Slack. It's flooded with error messages. And at that time, it meant usually no good. It meant we're not able to do much. Usually, the solution to the problem at that time was just throw more money at it. Just give these machines more CPU, more memory. It meant maybe we put one too many clients on the same box. Maybe that client that we onboarded the other day, it's a little bit bigger than we expected. Or maybe the database backups haven't finished from the weekend. This was just not sustainable, and our maintenance costs were just larger than any business would want. And we were blocking sales. So we made a big and scary decision back in 2019 to rebuild the engine from the ground up. In order to be there for our clients longer term, we needed to make this massive investment, both in terms of money and time. And this is what we came up with. This was our North Star: cloud native and share nothing. We were already big on AWS, and it just made sense that we make use of all of the managed services, not all, but managed services that work for us, so that we can focus on solving our business problems and our client problems instead of the technical ones. Cloud providers, including AWS in this case, they're pretty good at scaling up services, managing the backups, and patching the service. All of that undifferentiated work, we just let them do the hard work. We wanted to enable the work at extreme scale, improve our security, increase visibility, and also simplify our operations. And we have. By designing our systems to be able to horizontally scale compute, and by making sure we are not sharing infrastructure between different components of the system, but also between different clients. And again, where that made technical and business sense. Additionally, we made sure that we are using different storage solutions that fit the data better, that fit the problem that was trying to solve better. If you remember, like everything up to that point was in that monolithic relational database. And I'll just hint you, compressed JSON blobs, they don't really fit there. Today, I'm going to share with you 3 patterns that we used that got us to feel these benefits, that use these design principles that I just mentioned. 3 patterns, each one of them, got us closer to being able to migrate all of the clients to the new architecture. Clients of different shapes and sizes, with all of the features that existing platforms supported. As one of my colleagues said, it was like changing tires on a racing car while the car is still moving. It was challenging, and it was fun. I need some raise of hands at the moment again. How many of you are familiar with AWS components? Okay, good number. How about Google Cloud Platform? Okay, a couple more hands. How about Azure, however you pronounce it? Okay, cool. Well, We chose AWS. However, these patterns are composed out of components, which more or less you can find in any of these platforms. I say more or less so. And I'll try to point them out on the slide. However, if I'm wrong, I don't have experience with Google Cloud Provider platform or Azure, so correct me if I'm wrong. Let's try to take a look at the components. Step functions, we use them for orchestrations. They manage the workloads and connect the pieces together. SQS is queuing system. We use it to distribute the work, to fan out. S3 is a file storage, serverless one, and it's used for two things. It's used first for longer-term storage, mostly for those JSON blobs, and also as a temporary storage between those distributed steps so they know how to communicate together. Similar to DynamoDB, which is a document store. Again, two purposes. One is metadata pointing to those files in S3. And then the second one is a progress tracker. So this distributed system knows when all of the little components are done. Next, Lambda, simple compute. One of our Lambdas was adding 2 numbers, like whatever you need it for, that is really quick and small. And then Fargate and ECS. These are serverless computing. So Fargate is sort of a serverless Docker container. And at the moment, we spin up around 50 to 300 of these containers for each one of our clients. And ECS helps us do that. ECS will then just spin up them and its container manager system. The last one that I don't know how it maps to any of these is Aurora Serverless V2. It's a Postgres relational database, and what was interesting there for us is that it's able to scale up very rapidly and then scale down. And we use it for long-term storage. Let's now put these components together and introduce our first pattern, the compute, for distributing the compute. The rule engine uses step functions to orchestrate the work. The first part is partitioning the work, and instructions on how to partition the work are then stored in a temporary storage in S3. Those instructions are then going to be used by the next step, which is going to then send those instructions to SQS to fan them out. Each instruction is one message, as well as store that information in DynamoDB as a progress tracker. The step function will then loop there in a circle, checking this progress tracker, are all of the component, all of the little pieces done? And when they are done, it's going to finish and move to the next logical step. Let's say it's going to calculating those properties, if it was in the before one. So while the step functions are there running in a loop, we have a set of Fargate containers, the mini rule engines doing the work. They take one by one message and they do the compute. In the process, they'll also store data to the temporary storage, to DynamoDB, also to the long storage, but more about that a bit later. Depending on the size of a client, we will spin up 50 to 300 these Fargate containers at the same time for each one of our clients. And those clients that have more portfolios, that have a larger number of portfolios, will also benefit from a larger number of these containers, as they'll have a larger number of those smaller units to do. At the moment, we are using just a fraction of an AWS's limit, which is 1,000. And in future, if needed, we could even push that to 2,000 or 3,000. There is no need at the moment, though. And this is just for a single client. Because the compute is now isolated in each client's AWS account, we remove that factor of noisy neighboring. That means that if we have over 200 client environments, we could be potentially running 80,000 Fargate containers at the same time comfortably. And the size matters, the size of the containers. The smallest unit of work at the moment is running a single rule on a single portfolio. But as you remember, that portfolio could have millions of positions, which means we also adapt the size of the container depending on the size of the smallest unit. So what are the benefits that we are getting with this pattern? We removed the bottlenecks on the CPU and memory as we distributed the work, but also as we isolated the work. We removed the noisy neighboring effect. And secondly, these Fargate containers are not running all the time. They're being spun up as a client sends a position file, which means that all of this infrastructure, the compute, is not just sitting there and waiting for something to happen. So it means we have resolved our issues of underutilized infrastructure, saving energy, but also we are helping the environment. So we solved the computational problem. How about the storage? Remember, the storage is also shared. That's SQL Server. And we had two problems, at least. The CPU bottleneck at peak time of usage, when the rule engine is calculating these results and wants to store something to the database. And then secondly, as the rule engine is generating a lot of data, the storage is growing rapidly, and we started seeing backup issues. Now, the largest part of data is actually not the results that the engine generates at the end. Is the enriched position data, so the position data that client sends, and then that we enrich with additional properties like that price in euros. And that data is stored in a form of large, compressed, gzipped JSON blobs in a relational database, the SQL Server. It doesn't get any benefits of the characteristics of relational database. To put it a little bit into perspective, for one of our clients, at the worst, they had a database that was of 21 terabytes. And this enriched position data, these big JSON blobs, were taking 19 terabytes of that memory. That's 90%. That's just mental. So we needed some way to remove those large JSON blobs outside that relational database. And the tool for the job was S3. S3 as a serverless file storage system from AWS that is cheap and that is actually appropriate for these kind of data sets. It doesn't have very rich querying capabilities, but combined with S3 Select, it gave us just enough. We were able to, with S3 Select, just pull the data that we needed, either the properties or the subsets. And the problems that we solved with this, we just removed a lot of pressure of that shared SQL database. We are not storing that much data, but also we removed a lot of the existing data to S3, and the storage is not growing that rapidly, which basically lowered our maintenance costs. So we talked a lot about these like techie things, AWS components, a lot of buzzwords. And we tend to get lost as software engineers in that. But what is really important is, and the only thing that it matters is, does it work? Did any of this make any impact? And I wouldn't be here if it didn't, or the talk would be different. But it did. For some of our more complex clients, it made a significant improvement. And you don't need to believe me. You can read the email for one of our clients, the largest Canadian bank. It says, "Hi, today's XML file uploading process completed in 39 minutes. It usually takes 1 hour and 40 minutes to complete. Could you please confirm that this is due to the architecture upgrade that was done last night, and that there is no issues with today's processing? Have you started panicking when you read this? I mean, you haven't. But like normally, if I received an email like this, like, have we skipped all of the portfolios? What happened with the rules? What's gone wrong? We're quite cheeky this time about it, and we're quite pleased what we have done. Imagine you're saving 1 hour of your client's time. 1 hour a day that they could be spending bringing value to you, potentially their clients. Woo! Well done. So with these two patterns, distributing the compute and removing this massive amount of data from a relational database that really doesn't fit there, we were able to migrate 90% of our clients to the new architecture. And we have. But 90% is not equal to 100%. And the last 10% of clients were just too slow. The bottleneck was, again, the SQL Server. This is the same diagram, so you don't need to soak it in. As I said, what was the problem with the SQL Server again? We need to wind a little bit back. You remember those results that the engine generates at the end of the calculation process? Well, now, when we distributed that process, that huge amount of results is generated even faster, in a shorter amount of time. Have you ever tried writing 20 million records to the SQL database from 300 containers? We have. And since it was shared cluster, we crashed it. It was not a fun day. So for those 90% of clients that we were able to migrate to the new architecture, at the end of these calculations, we would store these results to S3. And then when all of that is done, from a single container, we will slowly start getting those results from S3 and slow feeding them into the SQL Server to not crash it, to not kill it, to not cause the incident again. However, for these 10% of clients, this was just slow. It was taking an hour. It was taking as much as everything else was in that process run taking. The tool for the job this time was Aurora Serverless v2. And before we integrated Aurora Serverless v2 into our system, it only existed, it was released like 2 months before that. So it's not like we could think about it before that. Aurora Serverless v2 is a serverless relational database. And what is interesting for it, as I said, what is interesting about it for us is that it can scale up really fast when those bursts of write happen. And then it can also scale down after those bursts of write are done, which made it cost-effective to be able to introduce to our clients. With introducing Aurora Serverless v2, we were able to migrate all of our clients to the new architecture. And we got rid of all of that over-provisioned, underutilized, self-hosted infrastructure. Oh yeah. So we even more removed the maintenance problems and improved our operations. With this, we have introduced all of the 3 patterns that we use to migrate all of our clients to the new architecture. We have enabled creating new products for our clients. We now are able to onboard more clients. And plus, a big bonus is we are no longer afraid of the biggest whales in the industry. The new platform is more stable. The file runtimes are more predictable, but also we have fewer incidents to deal with. It's also much faster for some of our more complex clients. You have seen that email from the largest Canadian bank, right? An hour faster. It's also cheaper. On one side, the maintenance costs have gone down, all of that weekend work, but also the incident stuff that we were dealing with, a lot of engineering effort that just doesn't need to happen anymore. But there is one thing that was actually even easier to measure, that was easier to see, our AWS bill. This is a diagram from last April, not this April. And the bottom two bars, the blue and red, represent the EC2 instances. Those are those big over-provisioned machines. The last two bars on the top, the green and purple, are the backups. And what's interesting there is, can you see where the weekend is? Yeah, you're trying to find it. No. It's the same. The cost is always the same because the infrastructure is always there. Now compare it to this. In blue, you have ECS. Those are those Fargate containers, those mini engines. And then the rest of it is the storage, whether it's long-term or whether it's short-term, whether it's relational database or DynamoDB or S3. We have decreased our database storage costs by 70%. And you can see where the weekend is, right? But that's not all. We have also made the rule engine better for the environment. Time for a sip. I really hope that your morning coffee has kicked in, because I want you to focus for the last 20 minutes. As I mentioned, I want you to leave this room with ideas, with questions, determined that when you go back to work on Monday, that you're going to do something about this. So find me after the talk and let's talk about it. But before we continue, it's time for a confession. The urgency for change for us came from a business risk. If you remember, it would be so much more expensive to support any larger and more complex clients. And we were worried that we would not be able to support them, which would be commercially dangerous. And if we are not profitable as a bootstrap scale-up, we would not be here to do any good. However, it is very important to us, as the first Tech B Corp in the UK, the need to reduce the carbon emissions, to think about the negative impact, and to think about the world that we are leaving behind. And the best we can do, the best you can do, is to not write any software, or to not run any software. And that is exactly what sometimes you need to do. Say no. Say no to the requirements, to the value that doesn't bring any value to your clients, that doesn't make your software better. Say no to ridiculous SLAs. However, the engine is an invaluable component to our clients. So we accepted that it also equals to energy cost. But what are we doing to reduce the negative carbon emissions and the negative impact? Other than to be able to scale up and support larger workloads, one of the main goals for us was to reduce the cost and remain profitable. And to reduce the costs, we have eliminated compute infrastructure waste by removing those long-lived, over-provisioned Windows boxes that were just sitting there and being always on, right? By eliminating compute infrastructure waste, we have also reduced the electricity usage. And electricity usage is often factored into the cost of running a service. The cost is usually also, electricity usage is often a good proxy to measuring also your reduction in carbon emissions. And at this stage, if you're at the beginning of your journey, the cost is the simplest metric you can use to measure the reduction in your carbon emissions. But if you're at the beginnings of your journey. When we are talking about data, that's exactly what you need to do at start. So you know if the changes that you're making make any impact, and actually in which direction. For us, collecting the data gave us visibility over options that we have, and we were able to choose those options, those changes that make the largest impact. And this is important. I don't want you to go and waste your time making every single little change that will make a tiny improvement. Make your work count. Choose those changes that will make a significant improvement. Don't go and optimize a server that's used by 5 users. And sometimes the data says you need to improve the performance of your service, but not by adding more service and using more electricity usage, but by writing your code a little bit more performantly, by making the rule engine, in our case, work smarter and not harder. For us, at this stage, majority of these performance changes could fit into 2 categories. The first one is the code didn't scale as well with the complexity of clients. When you onboard a new client, and these are not as easy to find as you might think, when you onboard a new client that is a bit more complex than the previous one, you expect their runtime to go up. However, what was proven to us multiple times is that the runtime doesn't need to go linearly up. It can be much more flat. And finding these performance bottlenecks is gold. One of our examples was removing toString on a model that was used just to support a legacy feature and that was running tens of millions of times during the engine run. Because we are being recorded, I'm not going to tell you how much time because it's embarrassing. So if you're interested, find me. The second one is what worked for the engine in a single process doesn't necessarily work for a distributed engine. And if you can guess, that's usually about the data access. As we re-architected our platform, we reused a lot of business knowledge, business logic. And we were kind of aware that some of these inefficient code parts are still going to be there. And once you find them, it's easy. You just figure out, okay, I don't need whole object and I don't need all of the data this often. The solution is usually just get me the data that I need or put a cache in between or sometimes both. And of course, there is a secret sauce, which without none of this would be possible, which is the culture, the people. We talk about it and we care. And all of this makes our rule engine greener. What else makes it greener? How many of you, now this is again a show of hands, are running any of your software in cloud? Is that everyone? Oh, cool. Not everyone? Yeah? Okay. I don't need to ask the second question. Actually, I do. How many of you are running all of your software in cloud? Okay, fewer hands, but cool. I'll explain why. So we chose AWS, and I'm not here to sell you AWS, not at all, but I'm here to sell you cloud. Looks like you're sold, but potentially a little bit of explanation why that is important. The calculation is actually simple. Cloud providers spend a lot of time optimizing their software and making the most out of the hardware that they use. They profit more as they optimize more, which in a lot of cases also means fewer carbon emissions. And you might not like it, but the the biggest carbon emission reduction you can get for the least of your efforts, if you are at the beginning of your journey, is to use cloud. And the cloud providers are really good. They're great at optimizing their servers, optimizing their machines, and make them work, reducing that time, that idleness. And it's not because they care so much about the environment. It's because effectiveness is tightly linked to being green and to cutting operational costs. In FundApps, we are working on reducing our carbon emissions, but we are not perfect yet, and we have not reduced it to zero. So, because we care about staying carbon neutral, we are offsetting our carbon emissions. And it doesn't just involve what our software generates. It also comes from what our office generates and what commuting to work generates, and us visiting the clients, maybe even me visiting this conference. You get the point. Maybe it's a good time to introduce what's the definition of the green software. And this comes from the Green Software Foundation. Green software is software that causes minimal carbon emissions when it runs. It means that it uses less energy and less hardware to do exactly the same job, but it also means it's carbon aware, which means it changes the behavior to reduce those carbon emissions. And we mentioned some of these things before. It's doing less, so being very critical on what value or what features you put in your service, removing that extra compute infrastructure waste that is not needed, removing those always-on machines, improving your performance bottlenecks, but also using the cloud, because why not use some work that someone else did for us? And because I'm so keen for you to leave this room determined that you're going to do something on Monday, if you are at the beginning of your journey, I'm going to give you some tips on where to start. And this comes from Building Green Software. The great news is, according to Building Green Software book, this one, is that you can cut down 50% of your carbon emissions without buying any expensive tools by exercising the power of being rubbish now, and by using the best ops practices of fine-tuning and optimization. This is where you start. Kill all of those zombie processes and servers. They're not doing anything. They're just wasting the energy. And then do the one-off exercise of resizing your boxes, as we tend to over-provision them, just in case. And at this time, do it manually and automate later if there is need for that. We don't need to be perfect at this stage. If it applies for you, turn off your test systems in the evening and at the weekends. And everyone here is already on the cloud, but if you haven't, or if you're not, move to cloud. And then once you're there, review your instance types. Can you make use of spot instances? Does anyone know what spot instances are? Cool. So spot instances are the instances that, let's say, AWS would hold in reserve. Those instances would be running just to meet the demand if it's needed. So instances are not used, but they could be used if needed, which means that if you're using those spot instances, all of a sudden, it could just be taken away from you. But also, what's very neat is that those instances would be running anyway, which makes them also a lot cheaper. And then, can you make use of auto-scaling instances for all of your spiky work? The next one is most of the cloud providers provide these energy-efficient instances with energy-efficient ARM chips. The trick is not every software can just run on it without any changes, so you might need to do some work on it. But once you go through all of this list, if you were really rubbish now, you would get 50% in your carbon emissions. And then the next step to take a look at is other green services and tools. And in most cases, these would be the cloud-native ones. It's just cloud-native ones, but used as they are intended to be used. And this is just because of economy of scale, or just how good are they in utilizing the hardware, like, let's say, serverless. And the reason why they're green is because that makes sense, that brings profit to those that are providing it, to the Microsoft, Googles, to Amazons of the world. And just a reminder, at this stage, cost is just good enough metric to measure the changes that you're making, if they're making any impact. How many software engineers do we have in the room? Okay, more or less of everyone. I'm a software engineer, and my question was, what about code efficiency? Can I just optimize my code? Unfortunately, after you resolve those performance bottlenecks, code optimizations are way down on the list, on the priority list. I'm sorry. Two reasons for that. Even if you optimize, sorry, I was about to say a word that I probably shouldn't. Even if you optimize your code very well and you're still running on those long-lived machines, you did nothing. It's still using the same energy and it's still using the same servers, same infrastructure. The second thing is, usually the programming languages that bring you the most code efficiency are not that easy to work with. So you're making yourself a disservice, your company and your colleagues, by introducing those programming languages. Why just not use programming languages that make you deliver the value faster? And then you let these optimizations to those who are building compilers. This is, of course, if your code is not used on a huge scale and you need those performance improvements. What you can do is use better libraries and tools and platforms that are already optimized, that someone else is optimizing for you. As green becomes more important, and as we push these tools and platforms and libraries to be better, they'll become even greener. But by using them, you're able to focus on delivering value to your clients without sacrificing the performance. And I'm absolutely sure that all of you are using already libraries like this. For encryption, for JSON serialization, you wouldn't go and write those on your own. And I'm not saying that you can't do it as well, but why waste your time on something that doesn't bring you any business value, that is not your core business? And selling green software is hard, selling it to the business that has other priorities. So let's try to bring it closer to make it even easier. Green software is cheaper. We covered this already. But by using the cloud-native tools as they're intended to be used, you're just making use of all of those optimizations that someone else has done for you for a cheaper price. Secondly, those auto-scaling instances for the spiky loads, you should definitely use them. Efficiency is tightly coupled with green, as I mentioned, and we're cutting the operational costs, which also comes in nicely with green software is performant. Again, good fit. One of the well-established ways to improve the performance of your software is by choosing the right storage layer. And when you choose your storage layer nicely, it not only makes your code performant, it also signals to the cloud providers what's your intention, how you want to use the data, and they can be much smarter about the resources that they put behind those storage layers. Green software is reliable and resilient, and a modern way of making your software more reliable is by making it resilient. Not with redundancy. With redundancy, you're just having there some extra resources that are sitting, lying around, often not used, and when you need to use them, they fail. So the modern way of doing it is with resiliency, just using the auto-scaling, auto-restarts, which are much more efficient. Green software is also more secure. Traditional way of protecting yourself from DDoS attacks is just to make those machines bigger so you can take the load in. But if you're being smarter about it, if you can detect those attacks, you can be much more efficient about it. And then additionally, addressing those zombie processes. First, you're reducing the surface of your attack, and they're just forgotten things that you don't want to think about. And you know what? This is not fine. Our planet is screwed. And I admit, we are not the biggest culprit here. But we are above aviation, and that's just mental. As techies, we are in the right position to make big changes. And we need big changes right now. Small individual actions will no longer cut it. So, measure what you can and pick your battles. Don't get stuck into detail. We still don't know what will actually work, but please don't get paralyzed by that. And green is not just a hype. Those companies, those software components and platforms that don't adapt will stop to exist. Not green energy will become too expensive. People will not work for those companies on those systems. Plus, there are regulations that will be coming in place where you're going to be charged for direct and indirect greenhouse emissions. So, we better get good at this. And I'm going to leave you with one last one that's stuck with me ever since I heard it from my CEO. Every dollar you choose to spend, every dollar you choose to spend is a vote for the future you want to live it. Choose wisely. Thank you. Any questions, I'll be here, and the green ones just need cleaning up. The rest is fine.